So in class, we've studied infinite series, which are sums of infinite sequences. But there's a specific type of infinite series that we will call the geometric series. So, in a geometric series, let's just imagine that we have the starting term a, and for each next term in the sequence that we're adding up, because we're doing an infinite series, we're going to multiply that starting a value by some common ratio r. Here we'll have the starting term a, then ar, and ar squared, and we're going to sum this all the way till ar to the n minus 1, and essentially we can call this the sum of ar to the n minus 1 from n equals 1 to infinity. So one thing about geometric series that makes them special is that they're very easy to work with. So here we have that special r value, the common ratio, and it's whether this series is convergent or divergent completely depends on that r value. So generally we can say that if r is less than 1, we can say that this series is convergent, which means that it doesn't go off to infinity and will eventually have a sum that is constant. But if r is greater than or equal to 1, then this series is divergent. So an important thing to note also is that we're talking about the absolute value of r, because this could be an alternating geometric series. So we want to just look at the absolute value of r and compare it to 1, and then we can tell whether it'll be convergent or divergent. So let's look at an example. So let's look at this sequence of numbers. So we have, we can see that the signs are alternating between negative and positive, and we seem to have some kind of common factor here that we can take out. So upon looking at it, we can see that it's 3. We can take out a 3 out of the sequence, and then in the sequence we're left with 1, negative 2, positive 4, negative 8, so it's still alternating, but now we can see that this has something to do with like a common ratio of 2. So we can say that the a term here, so our beginning term is going to be 3, and then for the common ratio that we're trying to find, we can see that again it's going to be something related to 2, but since it's alternating, let's call it negative 2. We can, seeing that this is indeed a geometric series, we can say that this is the same as the sum from n equals 1 to infinity of a, which would be 3, times r, which we decided was negative 2, to the n minus 1. So the whole point with this is once you have the series of numbers, you want to kind of massage them in a way to like get to the to this kind of general formula, ar to the n minus 1, because then we'll look at how you can analyze this further. But from here we can already say that since the absolute value of the r value is 2, we can call this divergent because this is greater than or equal to 1, so divergent.
Another thing that makes a geometric series a very easy series to work with is the fact that if it converges, you can easily find what it converges to, but through the use of this formula right here, a over 1 minus r. So as long as the r value is less than 1, which means it converges, then you can just simply plug a into this formula and r into this formula, and you will find what the series will eventually converge into. So let's start out with a specific example of one where we're going to find what it converges to. So our series is 1 over 4 to the n power. At first this might not seem like a geometric sequence or follow the same formula that the other geometric sequences are, but it is. And how we can manipulate it into looking like a geometric sequence is this one on top, it can have an implied n, or nth power. And that's because no matter what power you bring this 1 to, it's always going to be equal 1. So you can have the nth power there, even though it's not there. So then you can make this equal to the sum from infinity to n equals 1 of 1/4 to the n power. So just taking the n from the denominator and the numerator out. So now it's starting to look more like a geometric sequence. But we still need this to be n minus 1. So in order to get that, we'll take out a 1/4 from this to get this. And this follows more the basic shape, I guess, of what the geometric sequence should look like. So with the a, the r, and then the n minus 1 power. And you can do this because if you multiply these two, then this is 1/4 to the first power. So then when you multiply two bases, you just add the exponential. So it's n minus 1 plus 1, so then you just get to the n, which is equivalent to this. So that's what makes this possible. So then let's plug it into our formula from the beginning to find out what this geometric series converges to. So we'd get a is 1/4, and over 1 minus r, which is also 1/4. So we get 1/4 over 3/4, which is simply 1/3. Remember, kids,
Eat your vegetables. And if you have a geometric series in the form the sum from n equals 1 to infinity of ar to the n minus 1, and r is less than 1, you know that it's going to converge to a over 1 minus r. Thanks for watching.